My name is Tina Eliassi-Rod. For those of you who don't know me, I'm an assistant professor of computer science here at Rutgers University. We have 3 excellent talks for you guys. The first one is Dr. Deepak Agarwal, who's going to talk to us about recommendation systems, and he's from Yahoo Research.
Good morning. Thanks all for coming. Thanks for the kind invitation, Batu and Tina. So I'm going to talk about some problems, some recommender problems we have been working on at Yahoo. So before I begin, here are the list of my collaborators. Okay, so here is the agenda. So I'm going to begin with a brief introduction, and again the introduction would be through a motivating example, which is content recommendation on the Yahoo front page. I'm going to discuss why it's a high-dimensional explore-exploit problem rather than a supervised learning problem or a regression problem, which is common in statistics. Nevertheless, even though it's an explore-exploit problem, one could still use regression ideas to reduce the dimensionality of the problem. So I'm going to discuss some modeling which we have been doing in the context of some of these problems. I'm going to go and describe multi-objective optimization. So when you're doing recommendation, you don't necessarily optimize for a single objective. You may have multiple competing objectives, and so how do you do that? And again, I'll go through an example. And finally, I'm going to end with some summary and some challenges which I feel in this field. Okay. Okay. So here is the motivating application. So this is the Yahoo front page. Hopefully, you all have visited this page at least once. So as you can see, this page is populated with several content modules. So the one on the top, that's called the Today module. It publishes a bunch of stories from different areas, finance, news, entertainment, and so on and so forth. And I'm going to talk a lot more about this module later on in the talk. Then you have the news module, and then on the right-hand side you have something called Trending Now, which shows the trending queries on the web, obtained by mining our search log. So as you can see, this is a very complex recommendation problem. A user comes to the website and you have to populate all these modules with content. Those are the most popular queries, but they are also personalized, so every user does not see the same kind of queries. Okay, so this is the Yahoo front page. We are very careful of user experience on the Yahoo front page. There is a lot of editorial oversight which goes into producing content that's published on the page. We don't allow. That's right. And that's primarily because it's a Yahoo front page, and we don't want to compromise on user experience at all. We could have that. At the end of the day, it all depends on how things blend together on the front page, right? And that again depends on the kind of objectives you have in mind, right? Is your goal to maximize click? Oh, okay. We don't allow for that now, but it's possible. Okay. Okay, so here is the approach. So what we do is we try to show content that maximizes user engagement on the page, right? And again, the philosophy here is if the users are happy, they'll spend more time on Yahoo, they'll get addicted to Yahoo, they'll keep coming back to Yahoo, and revenue would automatically follow, right? So our goal is to make users happy. So some proxies for measuring user engagement. When you're running a recommender system like this, you need some proxies which you can measure real time and cater the content to user taste. So some proxies, so the most widely used proxy is click rate, right? What's the probability of clicking on an article which you show on the front page, for instance? And this is the most widely used proxy, despite all the imperfections. There are other proxies as well, like time spent after you click on the page, or the session length after you click on the page, and so on. So, but I'll come back to time spent later on in the talk. But for this talk, I'll focus on the CTR maximization problem. So again, here is the problem. So we have users coming to the front page. Each user, when he or she comes to the front page, is equipped with a covariate vector XIT. So XIT are a set of attributes which we know about the user, right? So this may include declared interests, declared information, like the user may register with Yahoo and tell us they are old users, they are females. It also includes covariates that are inferred by us by looking at users' activity throughout the Yahoo network, right? So we look at all your search queries, your ad clicks, your page views, and based on that, we infer that you're probably a finance user. You love finance. You hate sports, so on and so forth, right? So these are the covariate vectors. So user comes in with the covariate vectors, and we have to populate the page. For instance, on the Today module, there are 4 slots that are visible when you come to the page, and we have to select the best 4 articles out of a pool of K1. Trending now again may have K3, a pool of K3, and you have to select the best 10 queries for you and so on in the news article. Right? So this is the abstract problem, and again the goal is to show these things over and over again, large number of times. Muthu was talking about billions of transactions. We don't have billions on the front page, but it's not very small, right? So at the end of the day, you want to do this process over and over again and to maximize the click rate over a long time horizon, right? So that's the problem. So first of all, the first thing to realize is this is a high-dimensional learning problem, right? There are too many choices. Even for moderate values of K1, K2, K3, there are just too many configurations which you can obtain on the front page, right? And so brute force experimentation is inefficient, right? So, but the thing to realize here is there are many choices that are bad, right? And we have to come up with a strategy which can eliminate the bad choices very soon. So one strategy which we have found very useful is to have adaptive experimentation, right? So keep experimenting, but make the experiment adaptive so that you prune the bad choices very quickly and rapidly converge to the best one. Well, if there is an article like finance and you don't like the finance article at all, then that's a bad choice for you, right? You like the sports article, that's a good choice for you. So we should be able to figure out that you don't like the finance article very quickly and eliminate that from them. And that requires adaptation. Secondly, personalization is important, right? One size fits all is no longer the norm on the web. It used to be that way long ago, but today everybody's moving toward personalization, right? And so it is important to learn things at very fine granularity. So now that's all. That's a very good ambition, but as soon as you start learning things at very fine granularities, you leads to data sparseness. So we have a lot of data on the web, but still it's too little to learn what we really want to learn about each individual user and the user's affinity to items.
Are you sure the personalized version of the Yahoo page for me that we trying to do?
Yes.
For each person has a personalized.
That's the holy grail. Yeah, eventually that's what we want to do. Yes.
We have my.yahoo. We make it ourselves. We have my.yahoo.
Yeah. So my.yahoo.com is a personalized version of Yahoo, but that's something which you can configure to your own taste. So what we really want to do here is you just come to the Yahoo front page, you're in the browse mode, and based on whatever you have done in the past, we want to give you good suggestions, right? On my, you can go and configure things on your own, so that's a different kind of.
HIC is different from that.
Yes, right? The other challenge is the pool is dynamic, the user covariates evolve over time, CTRs change over time, right? So, okay, so let's assume, so this is how we are going to solve this problem. Again, I'm not saying this is the best solution, but this is what we do today. So in order to solve the multi-module problem, we assume that the modules are all independent of each other, and we do separate recommendation on each module. Okay, and if we can do better by incorporating the correlations among modules, I'm going to talk about that later. And again, even within a given module, there are multiple slots, so you get data from different slots. And what we do is we we reweight the data on multiple slots to normalize them to a data that comes from a single slot, right? So basically what we do is we say, okay, well, position 2 is twice, position 2 is 2 times worse than something compared to position 1. So what that basically means is if you randomly take an article and put it at position 2, your click rate is going to be half than what it would get. And that's just because the first position has more exposure than the second position. So we use these weights and reweight the data and then learn from all the models. Okay. So in the rest of the talk, I'm going to tell you how we solve a problem. So imagine there is a front page with only a single slot. You have a pool of articles, and you want to recommend the best article on that particular pool, right? So, and in particular, I'm going to focus on the Today module problem, right? And as I said, the goal here is to maximize clicks subject to constraints. So as you were saying, this is the Yahoo front page. So there are constraints which are imposed on what kind of articles we have in the pool to select from. And that's done through editorial oversight. So the editors make sure that the pool of articles which we have is fresh, they are diverse. It's kind of reflective of the Yahoo voice, right? So at any given point in time, we have a small inventory of articles to choose from, like 30 to 50 articles, but this inventory refreshes periodically, right? So this is what a typical curve looks like. So at the bottom here, this curve is the overall CTR of articles over time. Each curve here represents an article, right? So for instance, this curve here, so this article was programmed here, and this was the overall CTR of this article, and then it got taken out from the pool. So that's what the data looks like. Short lifetime, small inventory, but it refreshes periodically.
Why is it taken out? It's still not.
Yes, so that's the constraint part. So the editors, even though the CTR of, maybe that's a Britney Spears article, and the editor, and we know that if you keep showing Britney Spears, it will get more clicks, but that's not reflective of what Yahoo stands for. So they kind of want to ensure a mix of things, right? So this is where the editorial oversight comes in, which tries to preserve what Yahoo stands for in the long run.
Thank you for this for a few days. Other things and actually very
Well, yeah. So there are more complex reasons to that. So I can get into that offline. Like, for instance, if we have a Britney Spears article running for 2 days, most of the clicks we have will take users to Yahoo to Yahoo Entertainment. Now we also have ads on Yahoo Finance to show, right? So the mix of articles which we have in the pool is driven both by several business constraints as well as long-term constraints which we have in the system. So the editors know that at a broad level we have more display advertising to show in finance than in entertainment, and so just showing entertainment is going to hurt our advertising business in the long run. It's also not going to make user experience very fulfilling in the long run. So again, this is what we have done. So what we have done so far is we have tried to blend editorial oversight with algorithms. Right? So earlier content was served on the Yahoo front page purely through editorial oversight. It's just like a newspaper, right? You have articles, editors come, they create articles, they stitch together a newspaper, and the world, and it's there for the world to see. So what we have done is we've taken the editorial programming and the constraints into account, and then blended it with algorithms to serve the best article to a user when they come to the front page, right? And again, this is done by techniques I'm going to describe later in the talk, right? And this has been quite successful in terms of improving user experience on the Yahoo network. No, that's not true. That's not entirely true. So what we have is we have a dashboard kind of thing. So you're asking the right questions, but we have a dashboard kind of thing. What we do is we take the output of the algorithms and we create some visual displays which the editors can then see, and then they go, oh yeah, well I thought this is going to do really well, but it doesn't look like it was the right decision to. So they are impacted by these statistics, and that is incorporated into the programming. But it's hard to quantify how much improvement that brings to the system. But that's what. And so the methods I'm going to describe, again, they generalize to other properties at Yahoo. So there are many other places at Yahoo where we have the same problem. Like if you go to Yahoo Finance, the same problem. If you go to Yahoo News, you have the same problem, and so on and so forth. Right. So the method I'm going to describe now are kind of used at many other places at Yahoo, not just the Yahoo front page. Okay. How much time do I have, Deepak? 15 minutes? Do I have 15? Okay, great. Okay, so now the first thing I want to convince you is this is what is called an explore exploit problem. So what do I mean by that? So in order to understand this, imagine you have only 2 items in the pool to select from. Let's say you don't want to do any personalization. Let's say item 1 has a CTR, or click-through rate, so CTR is a very common term used on the web, of 2 in 100, right? So this article was shown 100 times, it got 2 clicks. The second article was shown 1,000 times, it got 25 clicks, right? Now if you adopt a greedy approach, you're always going to show item 2 to everyone else and not even consider item 1. Now that's not a good idea, because although the empirical CTR of item 1 is smaller than item 2, there is more statistical variation in item 1, right? It has the potential of being better than item 2. Right? So for instance, if you look at the statistical distribution of article 1 and article 2, there is a probability that article 1 is better than article 2. So not showing item 1 at all after getting that empirical statistics is not a good idea. You should explore the item 1